My microphone was off when I recorded my algebras. Oops. Oh well. It happens. I hate when it automatically does that and it resets settings on me. Oh well. All right. Let's get back in on this. We are going to be working with our complex numbers. So we did some adding and subtracting. We did some multiplying. Now we're going to look at dividing. When we have some real numbers and complex numbers, or if we have two different complex numbers, trying to divide these. And so we're going to start by trying to get the I out of the denominator. And if we just had an I down there, we could do that. We did that on Friday. When we have these complex numbers, like this guy over here, where we have 2 minus 5i, if I just multiplied by I, I'm going to write it down, but don't do this. If we just multiplied by like I over I, and tried to multiply that out, I'd have my 2i minus 5i squared. Well, that gets rid of that I, but now I have a different one in there. So instead of multiplying by I over I, what we're going to need to do is get the conjugate, which we've talked about before. That was when we force it to be a difference of squares. So when we're multiplying by our funny-looking 1, we're going to use what we already have in the denominator, our 2 minus 5i. But we're going to use those same terms, our 2 and our 5i. But instead of a minus, we use a plus. And since we don't have an equal sign here, we have to multiply by a 1. I do not have an equal sign that I can do the same thing on both sides. So when we do this, I'm going to multiply out our denominator here. We've got our 2 minus 5i times 2 plus 5i. So we're going to have our 2 times 2 giving us 4. And our 2 times 5i giving us a plus 10i. Then we're going to have our minus 5i times 2 giving us a minus 10i. And our minus 5i times plus 5i giving us minus 25i squared. So I'm just multiplying out our denominator here. I'm just going to leave my numerator exactly how we had it here.
Is it okay that I distribute?
Absolutely fine. I was just going to do that later when we were past the thinking about this part. Oh, I'm going to change the view because I've written very small and it's just easier for me to zoom it in than for me to stretch and make them bigger. If I'm ever writing too small up there, please let me know because on my iPad it's zoomed in really far anyway. And I can't always tell. Because from this angle, the screen is mostly gray. I can see that it's on and there are colors, but that's about it. But when we simplify this denominator, we have a couple of things we can combine together. Because I've got my 4, my plus 10i and my minus 10i. Those guys cancel out. And we have our minus 25 times I squared. What is I squared again? We simplified that on Friday. Negative 1. So I'm just going to put this down here again. I'm going to distribute this one on the next step. But if you distributed it already, totally valid. Because we're going to finish simplifying this. What is 4 minus 25 times negative 1? Yeah, that's 4 plus 25. 29. And then our numerator is our 4 times 2, giving us 8. And our 4 times 5i plus 20i. And you can write it like this, totally valid. Or we can split this apart into 2 separate pieces, because that might let us simplify sometimes, where we have 8 over 29 plus 20i over 29. Either way is totally fine. This way as a fraction, as a single fraction, or this way where it's as a real portion and imaginary portion of a complex number. Both are totally fine. Totally fine and 100% accurate. One of these will make your brain hurt. Worse. Not going to claim none brain hurty, but least amount of brain hurty is the goal.
My brain hurts.
I was going to say one will hurt your brain less. Pick that one. And we're going to practice this again on the right-hand one, finding our conjugate so that we can multiply it and we can simplify. You don't always necessarily have to write out every step in this part. I tend to because it's something that is not always intuitive, at least at the beginning. So let's look up at this one. We've got 2 minus I over 3 plus 4I. We are trying to rationalize this, which means I need the I out of my denominator. I don't have an equal sign, so I can't multiply both sides by my denominator. I have to rationalize. I have to get rid of the I in the denominator. So what are we going to multiply by to get the I out of the denominator? 3 minus 4I. It's the same pieces, opposite sign. We're forcing it to have complete the square. Or we're forcing it to have a difference of squares, excuse me. I'm good at words. And since we don't have an equal sign, I cannot just multiply by my denominator. I have to multiply by a funny looking 1. And it is a weird looking 1. 3 minus 4I over 3 minus 4I. It would cancel out to be a 1. That doesn't help me if I cancel it out right here, though. So we want to multiply these two pieces together. And if you want to do all your multiplication at the same time, totally fine, 100% valid. I like to start with my denominator just because it lets me keep eyes on stuff and make sure things are coming out the way I want them to. I've got my 3 times 3 giving me 9. My 3 times minus 4I gives me a minus 12I. My 4I times 3 gives us a positive 12I. I can see those i's are going to cancel out. I'm happy about that. And then we have our minus 16I squared. I am also going to do my numerator right now. You do not have to. If you want to do these in 2 separate steps, totally valid. But I know we have a tendency to go, I do not want to write that many lines. So how many things can I do at once? So we're going to have our 2 times 3 giving us a 6. 2 times minus 4I gives us minus 8I. Have our minus I times 3, so we have minus 3I. And minus I times minus 4I gives us a plus 4I squared. Multiplying all our pieces out. Combine our like terms and simplify what we can. So we're going to have our numerator, we've got our 6 minus 8I minus 8I minus 3I.
11.
Minus 11I. And then we got 4 times I squared. Well, we know that I squared is negative 1, so you can either think of it as plus 4 times negative 1. You can simplify that to be minus 4. You can combine it with the 6 right here, but I knew I was going to have another row anyway, so I'm just leaving it like this. In our denominator, same vibe. I'm going to have my 9. Minus 12I plus 12I cancels out. We have minus 16I squared. And again, I squared we know is negative 1. Got a lot of pieces here. And we're almost all the way to the end. Because we have our 6 minus 4. So we're going to have in our numerator 2 minus 11I. And what's our denominator going to be? 25. And again, you can write it like this, or I'll write it in these 2 separate ways. 2 over 25 minus 11 over 25, or 11I over 25. I genuinely do not care which way you write it. They mean the exact same thing. This is 100% the exact same thing as this guy. Occasionally, writing it like this way, you'll be able to simplify one of these fractions. Not super common, but occasionally. There we go. Okay. Questions on this one? These two. Because we're going to try this again. This is something we're going to see a fair bit. This using our conjugate. So I want us to really practice using the conjugate. as many times as we can. Okay. Two more, very similar. Got 1 minus 7i over 6 minus 2i. Question here? Oh, absolutely. Make your best. I'm so I don't drop him. I'm gonna read this, right? Okay, just double check.
Thank you.
All right. So, what? Whoa, wrong pen. Wrong again. What are we going to multiply this one by? 6 plus 2i over 6 plus 2i. Yes, absolutely. Perfect conjugate. We're going to multiply these out. I'm going to do a whole lot in one row. You can do this in as many rows as you need. Remember that we're multiplying these. Think of these as factors with parentheses on them. We're going to have our 1 times 6 giving us 6. And our 1 times 2i giving us a plus 2i. I'm trying not to shout it too loudly because I know some of you guys are working ahead. And if I'm chanting numbers at you, it makes things a lot harder. So we're going to have our negative 7 times 6 giving us our minus 42i. And our minus 7 times 2i gives us minus 14 I squared. And then our denominator, we get to do the same kind of stuff. 36. And eventually we're going to start to notice that we're going to wind up with just these two pieces, our first times our first and our last times our last. So you can 100% just write down these pieces if that's all you need. Because we know those middle terms are going to cancel out. We should always have those middle terms canceling out if we've set up our conjugate right. So as we get a little bit more practice for this and you start to notice places where you can skip a step or two, go for it. As long as you can reliably do that, you do not have to write as many steps as I can, or as I do. So when we simplify this, we're going to have our 6 minus 40i plus 14, because this guy's negative 1, this becomes a plus 14. And our denominator is going to be our 36 plus 4. So what is this fully simplified down? Or what do we get next?
20 minus 40i over 40.
Over 40. So if we combine our like terms, we get this. Yes, this one will simplify, and you can either do it as the one big fraction and go, oh, hey, wait a second, absolutely all of those numbers are divisible by 20. Totally valid. This is one of those times when it might be easier to split it into our two fractions, because if I split this to be 20 over 40 minus 40 over 40 times I, it's a little easier to see that I can rewrite this as our 1/2 minus I, or 1 minus 2I over 2. That would also work as one big fraction. So especially when you see common numbers in here where we're going, oh, that's going to simplify somehow, I recommend splitting them apart. It's not wrong to do them in single fraction, but it's a little easier if you split them apart into separate pieces. So this is our main answer. If you really, really, really like to have the one big fraction, it would be 1 minus 2I all over 2. We're going to do one more like this. And then we're going to look at some very strange problems that the book gives us to go, okay. Because they like to word things weird sometimes. And they do stuff in what I feel like is a backwards order sometimes. So we have to figure out what we're going to multiply this right-hand fraction by. in order to get our conjugate. What is our conjugate going to be? Negative 2 minus I. Don't overthink it. The fact that there's negatives all over the place here doesn't matter. Minus a palooza. Go for it. It's okay that there's negatives everywhere. We can deal with negatives. I just know when we see a minus and a minus in there, people are like, factor -1. No, just leave it be. Take negative palooza. I was like, you can do it, but it's just making things harder. So multiply these things out. I'm going to do less out loud on this one because I know as soon as I wrote this up here, you guys started flying, which is totally valid. I fully support it. But I'm just going to do this in pieces. I'm going to kind of go slow here. Oh, my eyes are starting to get a little bit you-ish. There we go. Denominator. Keep working through it. See how far you can get down. Make sure it matches up with what I'm doing. Combine our like terms together. What did we get as our final answer? Minus 11i all over 5. I'm right there with you. Or, again, I'm just going to split them apart. You don't have to. This one isn't going to simplify further. But if it fits your brain better, totally valid to write it like this. Negative 12/5 minus 11/5 I. Both of those are totally fine. Okay? So we worked with the conjugate before when we had radicals in the denominator. Works the same exact way with i's. Okay? So we'll see these conjugates come up as we're trying to rationalize things because we don't get to keep square roots in the denominator. So anytime we have an I in the denominator or anytime we have a square root in the denominator, we've got to rationalize it. We do not get to keep radicals in denominators. So then, I don't know why, but the book that does these, and then it goes into stuff that looks like this, which is stuff we've done before. Like, these aren't genuinely awful. It's just weird that they came after we talked about eyes, because it's kind of where eyes come from. And this is, this will, I believe, be the end of 2-4. 2-4 has a little bit of the solving stuff. Okay. When we're dealing with stuff that has square roots of negative numbers, switch them into i's first and then deal with them like all the stuff we've been doing. We don't need to sit here and work it like this. We don't want to because it's going to mess with signs. Because when we have the square root of a negative number, we have an I. If I rewrite this without the radicals, just simplifying stuff down, what is the square root of negative 36? 6i. With i's, I was like, when we're just doing this, we're only going to deal with positive. It's called the principal root. We don't need to put plus or minus when it's imaginary because imaginaries always come in pairs like that. So I'm not concerned about the plus or minus here on this part. We're just dealing with the i's. When we get into things like solving, we'll need to pay attention to that, but we'll do that in a few minutes. I'll tell you that. Since right now we're just dealing with expressions, we don't need to deal with that. So what about square root of negative 9? What's that? 3i. And then how about our square root of negative 100? 10i. And they're all being multiplied together. So we have in our numerator our 6i. And our denominator, 3 times 10 gives us 30. And I times I gives us I squared. But what do we know about I squared? It's not that it can't be in the denominator. What does I squared equal? Negative 1. So that makes this whole fraction negative. If you want to put it in the denominator, that's valid. I can also park it out front because I have a negative from that I squared. Our numerator, we have our 6i. Technically, this would work as an answer except for the fact that it can simplify. How does this simplify? As I say, you can divide both pieces by 3. We can also divide both pieces by 6. This is the exact same thing as if I had I over negative 5 or negative I over 5 or negative I over 5. We're just simplifying it down. So if you, when you look at the homework and do the problems that have square roots of negative numbers, switch them to i's. We know how to deal with I. We don't need to be extra. It's really, really important that you don't try and multiply your radicands before we switch them to i's, because I don't want to do negative 9 times negative 100 to get the square root of negative 900 to get my 30, or I'm going to lose my minus sign.
So the I squared negative is the entire fraction.
If you put it in the denominator, it's totally fine. It's just like having like negative 1 over 2 or negative 1/2 or 1 over negative 2. They all mean the same thing. As long as there's one negative sign, I can park it wherever the heck I want. I could write this, oop, wrong pen. Boop, there we go. I could put it as negative I over 5 or I over negative 5. They all mean the same thing. Whether I park it out front, I'm changing color so it's darker. So I put it out front, if I put it in the numerator, or I put it in the denominator. They all mean the same thing. Just don't tell me negative I over negative 5. Then we've changed it. Then it's a positive. So let's look at the one on the right. Very similar vibes. Square root of negative 36 times square root of negative 49 over square root of negative 16. What is square root of negative 36 going to be? 6i. What about our square root of negative 49? 7i. And our denominator? 4i. Where am my highlighter? There it is. There we go. 4i. So we can multiply these pieces together. If I multiply 6i times 7i, what do we get? 42i squared. And our denominator, I don't really have anything I can do with it right now. It just says 4i. So, we know our I squared, right? We know that that's going to be negative 1. So I could write this as our negative 42 over 4i. I'm just going to keep it pink. But am I allowed to keep an I in the denominator? No. What do I need to do to get my I out of the denominator? In a way. Yeah, we need to multiply by something to get the I out of there. Do I have any adding or subtracting in my denominator? No, so it's not a conjugate. We only need the conjugate if we have adding or subtracting, because then we have to make it be completing the or make it be a difference of squares. If I just have an I there, we are just going to multiply by I over I. When we multiply by I over I, I'm going to change the view just so I can zoom in a little bit. There we go. When we multiply by I over I, we get our negative 42i over 4i squared. We know I squared. I squared is negative 1. So then we have our negative 42i over negative 4. The negatives cancel. Is there anything else we can simplify? They're both divisible by 2. So we're going to wind up here with 21i over 2 as our best answer. So sometimes we won't have to rationalize if we do not wind up with an I in our denominator. Sometimes we will. Okay. Questions on this one? Let's see what I have next. Okay. We're going to do one more before we look at some of the solving stuff. Just sometimes they'll give us stuff like this, which looks super extra. Switch them into I's first, and then it's just like how we started today. Because I can rewrite this, our 7 plus the square root of negative 64 over 2 minus the square root of negative 81. Rewrite this without the radicals. 7 plus, what is the square root of negative 64? 8i. Switch it to blue. There we go. And our denominator, we have negative 2 minus the square root of negative 81. What's the square root of negative 81? 9i. Now we have adding and subtracting in our denominator. We have subtracting specifically. So that means when we try and rationalize this, now we need the conjugate. So you can do it up here with the conjugate. It's just super messy. I do not recommend it because that's a lot of radicals. Switch them to i's and deal with it here. Way easier. So what is our conjugate going to be? What do we need to multiply by? Boom. Do it. Negative 2 plus 9i. You got this. Multiply them out. I'm going to do it up here, and I'm going to try and go fairly slow so you guys have time, because I know you guys like to try and run ahead. Totally valid. Plus 72. Nope, that's not right. I'm good at mathing. Boom, there we go. Boop, boop. Multiply all our pieces out, then start trying to combine your like terms. Simplify as much as we can. Got our 63 minus 16. That's going to give us our 47i minus 72. We get 4 plus 81. And then we should wind up with I'm going to do it in these 2 separate fractions. As the you can do it as the 1 fraction too. Totally okay.
No, I thought I got my answers. Well, one of my numbers wrong, but I did it. Very fast.
I was like, it can also be me. I'm using my numbers from last year, not actually braining it myself. So
Valid.
that's part of the reason I keep all my notes from last year, so I don't have to restart them every year. But also why I write them up here with you guys. Keeps it all there. Okay. Questions on this one? Let's do a little bit more. Let's see. We're going to do... There we go. Just making it so we don't have to have two things on one page because I don't know how much we're going to get through and I don't want to try and speed run it for the second one. So let's look at this one. Oop, maybe. Hello. It doesn't want to work. So we're okay, fine. We'll use this page. Yes, dear?
You like cider cold or warm?
Cider, like you're talking like apple cider? Usually warm. Usually I'm a like warm, especially if you can do a caramel apple cider.
Starbucks has, oh my god.
That's my go-to fall not having coffee drink. Like if I go after school, it would be a caramel apple cider. All right. We have done things like this before. Because we could, look at this, just trying to solve it. We could try and factor it. We'd need a pair of numbers that multiplies to make 13 and adds to be negative 6. Is that something we do? We don't have a pair of numbers that'll factor to do this. So I wish we did, but we don't have one that'll work. So if we don't have a set of factors that'll work here, what can I do to try and solve this and get down to my solution of x equals? Oh, you could go for completing the square. That's totally valid. I was like, it's going to be not super pleasant. But you could do it. So we know this is not factorable. I'm just putting it up here. Non-factorable. So it's not factorable. Quadratic formula is probably the most comfortable way we have to go. You can 100% do our completing the square like we worked with last week. Will totally work. But I know of a tendency to go, I'd rather do this. So I'm just going to put our whole thing up. X equals the opposite of b plus or minus square root b squared minus 4ac divided by 2a. What is our a? 1. What is our b? Negative 6. And what's our c? 13. Substitute in our pieces. I know it feels like we made a big jump. I promise it's relevant. So we're going to have our opposite of negative 6 plus or minus the square root negative 6 squared minus 4 times 1 times 13 all over 2 times 1. So substitute all our pieces in and then work through starting to simplify it. We have our x equals opposite of negative 6 gives us a positive 6 plus or minus the square root. Yeah, we get a positive 36 minus 52. 4 times 13 is 52. So 36 minus 52 is a negative 16. What is the square root of negative 16? 4i. This is the same thing as if I had x equals 6 plus or minus 4i over 2. Can that simplify? Yeah, all of these numbers are divisible by 2. All my coefficients. You could also split this into our two fractions. I'll just make it so we can see better. Our x equals 6 over 2 plus or minus 4i over 2. If that helps you see it so that you can simplify it, do that. Because we should wind up with 3 plus or minus 2i. So we got a complex number as our solution here. But this is why imaginary numbers were invented. Because mathematicians used to be able to get there. And then they went, I can't get all the way to the ends. And it bothered them. So they made I so they could get all the way to here. Because mathematicians are a little bit crazy. They're mathematicians. It was by choice. So like, meh. I'm just zooming up so we can see it from the back. Okay, so our solving stuff, we're going to have some pieces that are a little bit weird. All right. Well, what we're going to do is I'm going to go ahead and we're going to stop right there. We'll do 2 more solving ones tomorrow. So what that means is homework 2-4 we will have due Wednesday. I don't want us to try and speed run it. So there's 2 more solving problems I want us to do. So we're going to talk through them tomorrow. Boop, there we go. Switching that. So I will switch that over. I already had it on Wednesday. Look at me planning ahead for that. Do Wednesday for 2-4. Okay, so there's a couple of solving problems. If you look at the solving problem and go, we haven't talked about it yet. So you guys have 4 minutes. Oh my gosh, look at me giving you time. I just didn't want us to try and speed run stuff because the next one is a little weird.